Assalamualaikum and hello to everyone. In today's lesson, we will continue with subtopic 2.4 in chapter 2. In this video, we will be looking at the third process regarding this subtopic. We have here the third process. The name of the process is shown in the video. Just to remind that for gases, the name in terms of PV by the power of n equals to C, n here is equal to 1. The line for this process is a curved line as shown in the figure given. However, this process line is only used for ideal gases. For boundary work equation, now to calculate the boundary work, we must first identify the type of substance from the question. This is because the boundary work equation is different between phase change substances and ideal gases. For water and R134A, the boundary work equation is obtained by calculating the area under the PV diagram. For ideal gases, we can use the following equation, which here is written in red, to calculate for the boundary work. For the first law energy equation, remember to write the general equation first and then rearrange the equation to find for amount of heat transfer for this process. Remember to expand the equation for delta U, and from here, students should know how to find the change in specific internal energy based on the substance. However, if we were to look at the equation for delta U, for gases, since the temperature is constant, delta U here is equal to 0. Now let's go through the first example for this process. You can pause the video to read and understand the question. For step 1, please try to draw and label the schematic diagram as shown in this video. For step 2, we will use the boundary work equation for this process to calculate the amount of boundary work. And for heat transfer, we will apply the first law energy equation based on the constant temperature process. Now, remember, since the substance in the question is a gas, we must still prove or show that delta U here is equal to 0. For step 3, even though that there are no properties that needs to be determined, we still have to write down what is given from the question for each state. For step 4, substitute and solve for the question, and don't forget to sketch the PV diagram because it was mentioned in the question. Okay, now let's go through the second example. You can pause the video to read and understand the question. For step 1, please try to draw and label the schematic diagram. You can use the piston cylinder device as the system. For step 2, now for the boundary work, since the substance is a water, we have to sketch the PV diagram first, and from the PV diagram, we can calculate the boundary work for this process. For the amount of heat transfer, we will apply the first law energy equation. But first, please be careful not to cancel the equation for delta U because now the substance is not a gas. For step 3, determine the required properties at each state. Remember to check for the phase at each state. For state 1, since the phase is already mentioned, we can open the required table to read for the properties below. Now, as you can see, we have read for the value for pressure, The reason why we read the value for pressure is that, remember, the boundary work is calculated based on the area under the PV diagram. Therefore, we need the value for pressure later for our calculation. For state 2, since quality X here is given, we know that the phase is a mixture. Therefore, by using the equation for mixture, we can calculate for the properties required. For step 4, now let's try to sketch the PV diagram to calculate the area under the graph. We have here the PV axis. Please remember to draw the saturation line. The line passing through the saturation line is the constant temperature line. We can now plot for state 1 and draw the process line until state 2. Next, we can try to calculate the area under the graph. So, as you can see, from the PV diagram, we can see that the equation for the area under the graph is basically the equation to calculate the area of a square. So, the equation is as follows, and by substituting the required values, we can solve for the amount of boundary work. For amount of heat transfer, substitute and solve by using the first law energy equation. Now, the third example here involves a combination of two processes. You can pause to read and understand the question properly. Please do not be afraid if there is more than one process involved. Treat each process individually and be careful with the states involved for each process. For step 1, since there are two processes, state 1 and state 2 are for the first process, while state 2 and state 3 are for the second process. Please try to draw and label the given schematic diagram. For step 2, even though the question asks us to sketch the PV diagram first, it is safer to draw the PV diagram once all the value for pressure and volume at each state is determined. The specific volume at state 3 can be solved using the following equation. The total amount of boundary work is simply the addition of the boundary work for each process. Calculate each boundary work individually and only then add them up. The total amount of heat energy is also the addition of the heat energy for each process. Calculate them individually and then only add them up. For step 3, just like in previous examples, find the required properties at each state, state 1, and then state 2, and finally state 3. Also remember to calculate the specific volume at state 3. Now, once all the required properties is known, we can then sketch the PV diagram. Here we have the PV axis. From state 1 to state 2 is the isothermal process. We can read the values for state 1 here. We can also read the value for state 2. And then for state 2 to state 3 is the second process. And we can see here that the pressure is constant. And we can also read for the value specific volume at state 3. For step 4, substitute and solve for the required answers. Please try again this question without looking at the mathematical steps. We have come to the end of the video. So I will be seeing you later in another video for the remaining process. So for exercises, please refer to the original notes and past year examination papers. If there are any questions, you can leave a comment at the related forum section. Thank you and have a good day.